Okay, now do you see my little whiteboard?
Yeah.
Okay, perfect. Okay,
Are
so,
we gonna be able to here?
well, I hope not, but you guys will be ahead of the game. So, because we're going over negative exponents. So, I don't know why there isn't anybody here. Anybody else
Yeah,
here?
give me a second. I'll see if I get some.
Okay. Okay, so Katie, do you still, just let me know, do you still see my screen with the whiteboard?
I still see it.
Okay, good. Okay. 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 Okay, well, I'm gonna go ahead and start, and if someone comes on, then they can join it. Okay. So yesterday when you guys did scientific notation, you guys did it with positive exponents. So you did something like this, like if you had 3.8 times 10 to the second power, you would just look at your decimal, and then you find your decimal, you look at the exponent and know that I'm going to have to move my decimal 2 spaces. And since it's positive, I'm going to move my decimal 2 spaces to the right. So I would end up doing something like this, and I'd go 1, 2, there's my new decimal. I'd put in a placeholder, and I'd write down my answer. So 3.8 times 10 to the second power is 380. Okay, and along with that, you guys did it in reverse. So if I gave you 380, you would have to figure out how to write it in scientific notation. So in the number 380, you'd find the decimal, and in a regular whole number, it's always at the end. But you need to move it, so you create a number that's 1 or greater and less than 10. So I would need to move it right here. So I would get 3.80, which is the same thing as just 3.8. I'd have to multiply it by a power of 10 in order for it to be in scientific notation. The way to get my exponent is to go back and figure out how many spaces I've moved my decimal, and I moved my decimal 2 spaces, so I know it's a 2. And when I moved it 2 spaces, I know I'm going to have to move it back 2 spaces or to the right to get back to my original number. So that's why it's a positive number. And obviously, I'm starting with 3.8 and multiplying it to a number, and I got to get to 380. So it makes sense that my decimal would need to go to the right to make it 380. So today we're just going to do it a little different, to where we're going to do it with negative exponents. So let's say I change this problem up here. I'm going to use the same numbers, but let's say I put a -2. And some kids will think then that makes your answer negative, but that's not what it does. If I cover up this part right here, you guys already learned what to do with this in the last section when we started doing negative exponents. You guys, if you remember, with a negative exponent, that means you flip your base. So this number really is 1 over 10 squared, which is a fraction. So you're multiplying 3.8 times a fraction. So your number should get smaller. So what you do is you write down your number, you find where the decimal is. Well, there's my decimal. I know I'm going to move it 2 spaces, but now I'm going to move it 2 spaces to the left because it's negative. So I'm going to go 1, 2, make my new decimal. Any swoop I have, I fill it in with a 0. I rewrite what my number is. And if I don't have a number in front here, I need to put a 0 as a placeholder. So this number is 38 thousandths. So it's a really small number. So negative exponents will always result in a really small number, or smaller than what this is. Okay. So let's try another one, just real quick. So what if you had something like 4.056, and I'm going to multiply it to 10 to the negative third power. Well, there's my decimal. I can already see it. So I know I can rewrite it like this. And then I'm going to move 3 spaces. But since it's negative, I'm going to move 3 spaces to the left. So my decimal is going to go 1, 2, 3. Put my new decimal. Put zeros in for the swoops. Rewrite my answer with all the significant numbers. Now, if there were some zeros past here, you wouldn't need them because that doesn't affect your answer. But this 0 you do need because it's between 2 significant numbers. Now, there's no number in front, so I need to put a placeholder 0, and I'm done. So this scientific notation is this number. It means the same thing. So these two things mean the same value. One is written in standard form, one is written in scientific notation. Okay? Okay, now the other way you're going to have to do it is, what if I give you a number and you have to put it in scientific notation? And yesterday I gave you large numbers. Today I'm going to give you small numbers. So what if you had something like this? 0.0083. And you had to put it in scientific notation. You're going to do the same steps. You have to move your decimal and create a number that's 1 or greater and less than 10. So if I move my decimal, I would have to move it right there to create a number bigger than 1 but less than 10. So if I move it right there, I'll have the number 8.3. Now there'd be a bunch of zeros in front, but that wouldn't change its value. If there's zeros in front of the number and then 8.3, the number is just 8.3. Now I'm going to multiply it to a power of 10. I got to go back up and see how many spaces did I move it. 1, 2, 3. So I know this is going to be a 3, but I got to figure out which direction that I went, or do I need it positive or negative? Well, if I keep it positive, that means this is going to go this way and make a large number. So I need to make it negative because I need it to go back to this original number. Okay, so this right here is that number in scientific notation. Okay, so if I gave you this on a piece of paper and told you to write what its value is, you should get that answer. Okay, so when you're doing these, you're not doing any math necessarily. You're not actually solving 8.3 times 10 to the negative third. You don't have to plug it into a calculator. You don't have to do a bunch of math. You can, when you multiply by powers of 10, you're really just moving the decimal. So this tells you how many spaces it goes. This tells you if it's going to go to the right or the left. Okay. The other thing that you're going to run into possibly on your homework is identifying if something's in scientific notation. So let me give you a few examples. So if I have something like this, if I have something like that, you'd have to figure out, is that really in scientific notation? So you have to check for the 2 criteria. Well, one of them is you have to have a factor that's 1 or greater and less than 10. Well, this is a 40. So this is bigger than 10. So this isn't in scientific notation, even though it has this. This is correct, but this isn't. This is too big. So this isn't in true scientific notation. It does represent a number. You could actually solve that, get on a calculator, get a value, but it's not considered in scientific notation. Now, if I change this to 4.02, now it is in scientific notation. This factor is 1 or greater and less than 10, and it is being multiplied by a power of 10. So this is correct now. Okay. Now, what if you had something like this? Now you have to check again. Do you have a factor or a number that's 1 or greater and less than 10, which this is? This is like 3.5. So this is 1 or more and less than 10. But this is not a power of 10. It's 8 to the negative 2 power. This is not a 10 here. It has to be a 10 here. So this isn't in scientific notation. Okay? So you got to be careful about those. Sometimes they'll look like this as well. They'll do something like this: 0.2 times 10 to the third power. Well, this is correct because you have a power of 10, but this isn't even 1. This is less than 1. And remember, it has to be 1 or greater and less than 10. So this isn't in scientific notation either. Okay? Okay, so we're going to practice a few. So I'll stop there and answer any questions. So hold on.